Welcome back, race fans, for our next lesson in our pre-calc trig class. Today we are going to talk about dividing polynomials, and we're going to look at that section 2.4, but today we're going to look at B of dividing polynomials. So in the previous section, in section 2.4a, we ended up dividing polynomials using long division. And today we're going to look at something totally different in order to get to the same result, and it's called synthetic division. So we're going to title that up here, some synthetic division. All right. So when it comes to synthetic division, we're still going to start off with, some polynomial. And let's say we have x to the third plus 4x squared minus 5x plus 5. And all of that is being divided by x minus 3 to start with. Right? So there are some limitations when it comes to dividing polynomials, and what that limitation is looking at what we are dividing by. And we recall this little piece that we are dividing by, that's called our divisor, right? And I'm going to put a little asterisk over here. So our divisor has to be in x minus c form. Right? So when I'm working on these problems, I'm going to move this guy out of the way a little bit. We'll go like this, right? That's our divisor. And it has to be in that x minus c form. So what I like to do, I like to actually sit there and write it out. Like this needs to be our x minus, and I started putting the c in a box. And I think that kind of helps us when it comes to making sure we're figuring out if our c is supposed to be a positive or a negative number. So when I look at this problem now, my x, my minus, and then my c has to be a 3, right? So on this one we know that our c is going to equal 3. And I'm just going to write that down here for a second. C equals 3, right? So this is where that limitation comes in when it comes to long division. In order to be able to, to use synthetic division, in order to use synthetic division, you have to have that x minus c form, right? All right. So now how do you set up synthetic division? So you take whatever your c is, and I'm going to put that out front, and I'm going to put like a half of a box around it so it separates it from the rest of what I'm going to write, right? So now I'm going to go through and I'm going to look at my coefficients of each one of my variables, making sure that I'm in highest to lowest and all of my variables are covered, right? Or all of my degrees are covered. So here I have x to the third. So what's technically my coefficient out front? Really, it's a 1. There is a 1 there, we just don't write it, right? In front of x squared, I have a 4. So then now in front of my x, I have a negative 5. And then in front of my whole number is going to be my 5, right? So now I'm just going to write each one of those coefficients with a little space in between just to kind of keep them separated. So I have a 1, a 4, a negative 5, and a 5, right? That 1 came from here, this 4 is right there, this negative 5 is here, positive 5 is here. C equals 3, that's where that came from, okay? Ultimately, I'm going to fill in numbers underneath, so I'm going to give myself a little bit of a space, and I'm going to draw a line, right? So the first thing we always do is this 1, we always drop it down into that first spot, okay? To get our next number, it's just going to be 3 times 1 is 3. Okay, and then that's going to go there. And then I'm going to add these numbers. 4 plus 3 is 7. Then I'm going to go through and do that process again. 3 times 7 is 21. So then I'm going to add 21. I'm going to add these together, and I'm going to get 16. Right? Following? I hope so. 3 times 16 is 48. And I'm going to write 48 in that next little spot. So 48. I'm going to add those together, and I'm going to get 53. I think my video is lagging a little. So then what I do is this last number, I always throw it into a box, because this is actually showing me what my remainder is. So this here is my remainder. And then this is gonna, oops, let me go to here. This is my whole number, or my constant term. This becomes x, this becomes x squared. And if there were more terms, then you'd have like x to the third, x to the fourth, x to the fifth. It just kind of keeps going up, right? So a lot of times I like to write it. This stays as my whole number. This becomes my x. This becomes my x squared, right? Maybe I'll write that in a different color for you guys. Right? This is my whole number. This becomes x. This becomes x squared. So then now I can write my answer, right? 1x squared, or I could just write it as x squared. It's a positive 7x and a positive 16, plus a positive remainder of 53 over, what did I divide by? X minus 3. And there is your final answer. Well, then let's move on and try another one. I think I have a couple problems for you guys. X squared plus 14x plus 45 divided by x plus 9. So first thing I'm going to do is I'm going to try and figure out what my c is. So under my divisor, my x plus 9, I'm going to write it as x minus, and I'm going to put that c in that box, because I got to figure out what that c is in that box. And tell me if I'm wrong, but it just hit me like yesterday. I'm like, you know what? I wonder if it would be easier if I started writing it this way, even like when it came to vertex form and all this good stuff. Because I know a lot of times we just want to sit there and say that our c is whatever that number is. But we got this little negative we have to contend with or keep in mind. So when I look at this problem, because I had x minus c, well, how am I going to get it to be a positive? Well, if this is a negative and I need it to be a positive, it's got to be a negative 9, right? So really this should be x minus, and then in my c it would be a negative 9, right? Because that negative is going to make that a positive. So let me know if it helps, but I think it might. So, all right. So now we're ready to do the little synthetic shuffle, right? So in my little box, I'm going to put my c, and my c is negative 9. So I got negative 9, and I'm just going to throw that in that little box. I'm going to look at my polynomial, and I'm going to make sure that it is in descending order, so from highest degree down to lowest. My highest is 2, and a 1, and there isn't one. And then I'm going to make sure that all my variables are covered, right? All of my degrees are covered. So do I have an x squared? Yep. Do I have an x to the first? Yes. Do I have one with no x? Yes. Right? Then I'm going to look at those coefficients out front. So this guy, and this guy. And so in front of my x squared, I have a 1. I'm going to give a little space. In front of my x is a 14. And then I have my 45. I'm going to skip down, and I'm going to draw a line. What's the first thing I do? I drop down the 1. And then now I'm going to do negative 9 times 1 is what? -9. Yep. I'm going to add those together, and I'm going to get 5. Ooh, I'm lagging. So to get my next number, I'm going to do -9 times 5 is going to be what? 45. -45. I'm going to add those together and I get a 0. Always put that last number in a box because that is going to be your remainder. So we have a remainder of 0, so we don't have a remainder, right? So the first number is always going to be your whole number, and then your next one is going to be your x. So what's my answer going to be? X plus 5. And if you want, you can put the 1 out front if you need to, right? And we don't have a remainder, so there we are with our final answer. Sound like a plan? Alright. One more synthetic for you. How's that? It's like this is, it's not bad. I think it just takes a little bit of practice going through these problems. And I think you guys can become some pretty good experts on this. Alright. So let's go with 5x to the third plus 6x plus 8 divided by x plus 2. First thing I'm going to do is find my c. So this would be x minus my c. So x minus what is going to get me up to a positive 2? Yep, this has got to be a -2. So what's going to go on my little box on the outside? My -2, right? I'm going to look at my polynomial and make sure that it's going from highest to lowest. So I have my x third, then I have x to the 1, and then my whole number. So it is going in descending order, but guess what? What am I missing? Yeah, I'm missing an x squared, aren't I? There's no x to the square, right? Which would have fit like right in here somewhere, right? So I have to have that place filled. So because it's not there, it's the same thing as 0 times x squared. So you get two choices. You can just go ahead and write it into that synthetic form, or you can rewrite out the whole entire polynomial just so that you can see where that x squared should be, right? So if we were to rewrite it, it would just be 5x to the third plus 0x squared plus 6x plus 8. And sometimes it helps a little bit when it comes to knowing that you need a 5. You got to have that 0 to show that x squared place, and then a 6 and the 8. Right? I'm going to draw a little line. First term always gets dropped down, which is a 5. -2 times 5 is -10. I'm going to add these guys together and get -10. -2 times -10 is going to give me a positive 20. 6 plus 20 is 26. 26 times -2, we're just going to double that to -52. Add those together and we get a -44. Last number always goes in the box, because that's showing us that's our remainder, right? And then our first term is the 26 is going to be our whole number, and then we're just going to start going up, right? This would be our x, this would be our x squared. Like I said, if there was more terms, x to the third, x to the fourth, x to the fifth, right? You could keep going up depending on how big your polynomial was. So what's our final answer going to be? it's going to be 5x squared minus 10x plus 26. And then our remainder is negative, so it would be minus 44 over what is it we were dividing by? X plus 2. And that would be your final answer. Alright, I got one more thing to show you guys. So let's say we had some function f of x equals x to the third minus 4x squared plus 5x plus 3. We've seen functions like this all the time, haven't we? It's just a third degree polynomial, right? We can graph it, we can try and factor it, we can try and do a lot of stuff with it, right? And we can evaluate it. So we should recall, like if I gave you guys f of 2, what does that mean? Well, it means wherever there is an x, you're going to plug in a 2 to figure out what the y value is, right? So this would have been 2 to the third minus 4 times 2 squared plus 5 times 2 plus 3, right? 2 to the third is 8. 2 squared is 4. 4 times 4 is 16, so minus 16. 5 times, 16 plus 5 times 2 is 10 plus 3, right? 8 minus 16 is going to give you negative 8. Negative 8 plus 10 is going to give you a positive 2. Positive 2 plus 3 is going to give you a 5, right? So there is this really cool thing, and it's called the remainder theorem. So what the remainder theorem says, if you do synthetic division, whatever your remainder is would also be the solution. So in our little box, how we're doing f of 2, remember this 2? That 2 is what goes in the box, or a little half box, right? You do synthetic division the same way. You're looking at that original. It's highest to lowest degree. All of our degrees are being covered. So our x to the third has a coefficient of 1. Our x squared has a coefficient of negative 4. X has got the coefficient of 5. And then we have our 3. Okay. What do? We drop down the 1. 2 times 1 is 2. Negative 4 plus 2 is going to give us negative 2. Negative 2 times 2 is going to give us a 4. Negative 4. 5 minus 4 is 1. 2 times 1 is 2. 3 plus 2 is 5. And what's our remainder? 5. What? That just made your day, didn't it? So when it comes to evaluating functions, you have choices. You can go ahead and do it how we've always been doing it, where you're putting it into the whole equation, the whole formula, or the whole function, and figuring out what f of 2 is, where f of 2 is a value of 5, right? So when x is 2, y is 5. Or the other way you can do it is you can actually do it through synthetic division, and whatever your remainder is how it's what it would be evaluated at 2. So you have choices, you have options. All right. If you got any questions, reach out to me. I'll see you guys later. Have a good day. Bye.